previous video, I talked about the fact that our predictors have to be fixed, so they have to be sampled appropriately from the population. The next is it's not just appropriate for them to be sampled in the appropriate range, but they also have to be linearly related. That is, a lot of times you'll see that they're linear models, as in blue, best linear unbiased estimates. Well, the linear in this case really means rectilinear, straight line. And the assumption here is that the expected values for predicting y, so expected values of y or y hat, is a linear function of the predictors. And the easiest way for you to see this is just a very simple bivariate plot, where here I've plotted the raw data. The observed values are the black circles, and the expected values are these red circles. They're open circles. And as you can see that the red circles are a straight line. That's what we expect. Now, of course, we don't expect all of our observations to fall on that straight line, but we do expect there to be a linear relationship between, in this case, x and y. Now, the problem gets a little bit more difficult when you start thinking about multiple predictors. And what we can do is I can create a new predictor in my data set, which I did, z, and I'm going to now create a planar plot, a plot of the plane, because now that we have x and z as predictors, the predictor now is going to be related to or the set of predictors are going to be linearly related, but they're going to be related in this flat plane. As you can see, this flat plane shows that there's a linear relationship between z and y and x and y. And those relationships are fixed, and that each incremental change in either x or z results in an incremental and linear change in y. And so therefore, the assumption that we're focusing right here is that for every single level of each of our predictors, there needs to be a linear gradient, a linear increase in our dependent variable. And that's an assumption that's important for us to have the best linear unbiased estimates, is that we have to have linear relationships. So this is a more complicated way of saying that blue requires a linear relationship. These assumptions are essential for meeting blue, and the next video I'm going to talk more about some of the more underlying statistical assumptions that come from Gauss and Markov. So stay tuned for that one.